Hello, we are going to be working on solving rational equations. This comes from section 7.5 of your textbook. The big difference between these problems and the ones that we were doing before is this word solving. Okay, our goal on these problems is to find what, I'll just use x, what the variable or x equals. Okay, so it's a little bit different than we were doing before. Before we were just simplifying and they were all expressions. There were no equal signs. We were simplifying, adding, subtracting, multiplying, dividing. Now we are solving equations that have fractions containing polynomials, so these rationals. Okay, so there are two methods we're going to talk about, and depending on the way the problem looks is going to depend on which method you can or will use. Okay, we're going to start with the first method, which is solving by cross multiplication, and this is something that a lot of students say. And when we think about cross multiplication, cross multiply is actually you're multiplying diagonally. It's not straight across, but it's diagonally. And it's a play on this concept that we can multiply the denominator on both sides of the equation. It's just a shortcut. Okay, so this is a shortcut way to solve these problems, but let's read the statement underneath the title here. It says, you can only use this method if there is one fraction on each side. Okay, that is very, very important to understand when you can use this method. So you can use this method on every problem on this page, numbers 1, 2, 3, and 4. But when you go to the back of your page, okay, when you go to the back of your page, you cannot use this method because you do not have one fraction on each side. You have one fraction on the right, but this is two fractions. So if you wanted to cross multiply, you would have to combine these to one single fraction using a common denominator before you moved on with the problem. So on this page, numbers 5, 6, and 7, okay, you cannot use method number 1 of cross multiplication. Okay, cross multiplication is something that we can use when we have what's called a proportion. Okay, a proportion is when you have a fraction equal to a fraction. Okay, let's get into doing a couple of these problems. You will see in the directions, it says solve the following equations. Check for extraneous solutions. Now remember, extraneous solutions are solutions that you get that are not allowed to be answers for different reasons, depending on what type of function you're talking about. For us, the extraneous solutions are going to be solutions that would result in a denominator of 0. So remember, it's like those excluded values where we would say what values of x would make the denominator be 0. Well, for equations, we call them extraneous solutions. So it's the same idea as the excluded values that we had talked about before. Okay, number 1. First thing I'm going to do, and you probably know it, is I'm going to put parentheses around any of my polynomials that are bigger than one term, so binomials, trinomials, and such. Okay, so that will help me with my multiplication. First thing I'm going to do is notice that there is one fraction on each side, so I'm good to go with cross multiplication. I'm going to begin by multiplying diagonally the top numerator to the bottom denominator on the other side. So what does that look like? When you multiply, it's going to look like 3 times, there's my parenthesis, 4x plus 5. After you do that first diagonal, you need to put an equal sign. Then you move on to the other diagonal. The other diagonal is the top second fraction times the denominator of the first fraction. So you can see there's the diagonal there. So I'm multiplying 9 times this whole binomial. That's why the parentheses help. make sure you times by the entire thing x plus 1. The parentheses are there to make sure that you distribute into the binomials. So as you move on to the next step, you're going to go ahead and continue to solve like you would any linear equation. This is linear, it's going to be one answer. So I'm going to go ahead and distribute on both sides, and then you'll see it's a very simple problem from there. Let's subtract the 9x on both sides to give me 3x, subtract 15 on both sides, equal sign, subtract 15 on both sides, -6, divide both sides by 3, x equals -2. Before I circle my answer, let's look here. -2 would not give me a 0 here, and definitely not here either. So there's no extraneous solutions, so x equals -2 is my final answer. All right, let's look at the second one. For the second one, if you want to try it on your own, just pause the video, but I would just follow along with me. Again, parentheses here. I'm going to go ahead and do my cross multiplication now. For the cross multiplication on this problem, I'm going with the top times the bottom of the second fraction. That's really easy to do. 1 times 11x plus 8 is just 11x plus 8. After you do one cross multiply, you should put your equal sign. Then you're going to do this top x times that first denominator, so second numerator times first denominator. And I'm just going to go ahead and distribute this straight here in my answer instead of writing x times parentheses 2x plus 5. I can do that in my head. X times 2x is 2x squared. X times 5 is 5x. And you can definitely take that and do it all in one step. Or you can, take the extra step if you need it, like I did on number 1. All right, first thing we should notice on this problem is we have a highest exponent of 2. That should tell you that it is a quadratic. Remember, for a quadratic, highest exponent of 2 means we can get possibly 2 answers, right? And what we want to do when we solve this is we want to set it equal to 0. Very important that you understand highest exponent of 2 means a quadratic, set it equal to 0. It does not matter what side your x squared is on. That's your choice, right? So I'm just going to move all my terms to the side where the x squared is positive. So I'm going to have a 0 here, and then I'm going to subtract, bring down the 2x squared first. Don't forget that. And then I'm going to subtract 11x on both sides. There's the -6x, and the -8 on both sides. Nothing to combine with that, so you get this. If you don't like your x squared on the right-hand side with a 0 on the left, you can just use the symmetric property here and flip it all around. If you like it looking like that, go ahead. I prefer my 0 to be on the right, so it's not a bad idea to do that, but you don't have to. Okay, the next thing is, looking at this, you have 2 options. You can factor. This one is factorable. Or you can quadratic formula. And I'm not going to do that on this problem because I'm going to definitely check for, I'm going to definitely check to see if you can factor first. All right, when we are factoring, we should always look for a GCF first. This has a GCF of 2. And then continuing on with my factor, we have a guess and check problem. 2 binomials, x and x is x squared. You need 2 numbers that multiply to -4 but add to -3. So that's going to be a -4 and a +1. And then what we do at this point is we set each of these parentheses equal to 0. Some of you can do that in your head, but just remember, you can just think about that off to the side. It's x minus 4 equals 0, and you're going to set x plus 1 equals 0. You can just mentally think about what that is, especially because these are a little bit easier because there's no coefficient in front of the x. And you can see you're going to get x equals a 4 and a -1. from those two. Now, you have to check both of these, and I can clearly see that 4 is going to be fine, and -1 also going to be fine. So again, no extraneous solutions. You're not always going to have one. It's possible that one answer could be extraneous and the other one's not. It's possible that all answers are extraneous. If they're all extraneous, then it's going to be a no solution problem. I'm going to leave numbers 3 and 4 as extra examples that you can try on your own. It's just more of that cross multiplication. Okay, let's go to the back. Method number 2. In method number 2, what's nice about this method is that it always works. Okay? This method will always work. Unlike cross multiplication, with the cross multiplication, it has to be a proportion. 1 fraction equals 1 fraction. This is not like that. Okay, it says when you have more than 1 fraction on either side of the equation, you solve it by multiplying each term, and let's highlight that right here, multiplying each term on both sides of the equation by the least common denominator, the LCD, okay? And I said the least common denominator over 1 because when I have fractions, even if it's not a fraction, I like to put it over 1. That would be the first thing on number 6 that I would do. I would put that 1 over 1 so I have fractions. That would be the first thing. I don't think there's any more. No. Okay, so that's what I mean. Always make everything a fraction. It's a lot easier to see what's in your numerator and what's in your denominator. Okay, so here we are again, solving each equation, checking for those extraneous solutions. Now, here you have to be able to find your common denominator. Now, you're looking at a common denominator of all fractions on both sides. So it's not just the common denominator of the side with the 2 fractions. I need the common denominator of all fractions. So imagine I gave you these 3 fractions. Now, you don't need to write this down. Imagine I gave you 5 over x, 7 over 4, and -9 over x. What would be their common denominator? Okay? Think about what they already have in common. Of these 3 fractions, they already have an x in common. So I could very easily make this have the common denominator of, have x in the common denominator by multiplying it by x. So these ones that have x, what do they need that this one has? I'm circling it, right? It would need the 4. I could easily make these have a denominator of 4x. If I was making all the denominators the same, this would be your common denominator. So again, it's a denominator of all the fractions, not just some of the fractions. Okay, so let's go over here. Our common denominator is 4x. So what I'm going to do is I'm going to multiply every term on both sides by 4x. So the way that I set this up is I put a big parenthesis around each side. I'm going to show you 2 ways that you can sort of set this up. I like to put 2 parentheses on each side, and I like to say, well, I'm going to multiply this side by 4x over 1, and I'm going to multiply this side by 4x over 1. Okay? That's what we're doing. We're multiplying something to both sides. Whatever we multiply to one side, we have to multiply to the other. The other way that you can set this up is you can put one big parenthesis around the whole problem and say, I'm going to multiply all of that by 4x. Like that. Or you can write it in the front here too. Why do I put the parentheses? Because when I have something times a parenthesis, that in my brain tells me that I need to distribute. Okay? So however you want to set this up is completely on you. You will see if you were to look at my work that I would do both sides. I'd be like, I'm going to multiply this side by 4x over 1 by distributing, and I'm going to multiply this side by 4x over 1 by distributing. That's how I like to set it up. Okay? So your choice how you show that. Now, when we are multiplying by this LCD, the goal is that it will cancel out our denominators. So let's look at the first multiplication here. If I multiply, again, I'm going to do a little work here off to the side. If I multiply 4x over 1 times 5 over x, that would give you 20x over x. And wouldn't these x's cancel? They would go away, and you'd be left with just 20. So if you're multiplying by the LCD and you're doing it correctly, what should happen as you multiply is your denominators should cancel out. Okay? So if I multiply 4x times 5 over x, my x's will cancel out. I'll be left with 4 times 5, which is 20. Let's move on to the next one. It's going to be positive, so don't forget your plus. If I multiply 4x times 7 over 4, what will cancel? The 4's will cancel, and I'm left with x times 7, which we write as 7x. Bring down the equal sign. On the other side, it's a positive times a negative, so it's going to be negative. I'm going to write that down already. If I multiply these together, these x's will cancel out, and I'll be left with the 4 times the 9, or negative 9, however you want to think about it, and that's going to give me 36. And what you end up with is a very simple two-step equation. If the highest exponent is 1, we're going to get one answer. So as you multiply, think, if I multiply this, what will cancel? These will cancel, the x's will cancel, multiply what you have left. If I multiply here, my 4's will cancel. What will I have left? X times 7, write that down. Then go do that on the other side. Then we can go ahead and finish up this problem. Subtract the 20 on both sides. Divide both sides by 7. Check for extraneous solutions. Plugging in -8 here, fine. Plugging in -8 here, also fine. No extraneous solutions. There's your answer. Okay? All right, let's take a look at number 6. I know the box is quite big, so that way you have a lot of space on this problem here. Okay? So for this problem here, the first thing that I would do is I would write that 1 as 1 over 1. I think that it makes it a lot easier if every term on both sides is written as a fraction, even those whole numbers. Okay, so looking at these denominators, we need to think about what we are going to multiply both sides by. We need an LCD. So we have also, parentheses right here around the x minus 5. Put that parentheses around that x minus 5. I should have done that right at the beginning, okay? It's just a reminder. So this denominator has nothing. It's just a 1. So I'm not even going to like really consider it too much because it's just a 1. On these ones, though, this has an x. This has an x minus 5. So that means that this one is going to, so if we have an 8 over x minus 5 and a 3x, that means that this one has an x minus 5, so this one would need an x minus 5. So that means it's going to be part of your common denominator. So imagine you did this. We're not going to do this, but let's imagine that that's what we were doing. And so if this is what this fraction has, this one would need it too. So that means it also would need an x, right? So our common denominator here is x times x minus 5. We've seen things like that before, okay? Now, this denominator doesn't have any of that, and that is totally fine. We're not making the denominators the same. We're canceling out the denominators, okay? So what you're going to do is you're going to multiply both sides by this x times x minus 5, okay? You can distribute that and then multiply both sides by it, but that will make it really hard to do. It's a lot easier to keep it in its factored form, okay? So I'm going to recommend that when you go to multiply both sides, that you're going to keep it in that factored form. Okay. So let's go ahead and try this. Again, I'm going to rewrite this a little bit neater. So I have 1 over 1 minus 8 over x minus 5 equals 3 over x. Okay, so let's go ahead and keep this in its factored form and multiply both sides by x times x minus 5. So I'm going to multiply this side by x times x minus 5. I like to write it over 1. I don't know, it just helps my visuals to see what's at the top and what's at the bottom. And then I'm going to multiply the other side by the same thing. Okay, so that's what we have. What we're going to be doing is we are going to be distributing that here, and we're also going to distribute it here. As we multiply, we ask ourselves, if I multiply this first one, will anything cancel? The answer is no, because there's just a 1 here. So none of this is going to cancel. So you're left with x times x minus 5 times 1, which is just x times x minus 5. And I'm going to just leave it like that for now. I'll deal with the distributing after I've done all of my multiplying up here. Okay, the next thing, you have a minus sign. So I'm going to put that minus sign down there because a positive times a negative will give me negative. Multiplying this to this second fraction, okay, what's going to cancel? The x minus 5s will cancel. What are you left with? X times the 8. So that's 8x. So what you should be doing is when you multiply, say, what cancels? What do I have left? And whatever you have left gets multiplied together and brought down here, okay? If you distributed this, that's okay. I'm going to wait and do all my distributing when I go to the next step. Bring down your equal sign, go to the other side. On the other side, multiplying to the 3 over x. Ask yourself, what will cancel? The x's will cancel. What will I have left? I will have a 3 times the parenthesis x minus 5. So this is what you're left with, a multi-step equation. Okay, from here you should be able to finish solving it. Remember, when you are solving, the first thing you should do is distribute. That gives me x squared minus 5x. Bring down the negative 8x. I'll use that in the next step. Equals, distribute 3x minus 15. Okay, we have some like terms here. I'm going to go ahead and combine those. As I'm combining those, I see that I do have a highest power of 2. So just like on that other example, if I see a highest exponent of 2, that's a quadratic, which means you need to set it equal to 0. So I'm going to bring everything to the left-hand side. I like my x squared term to be positive. So I'll subtract 3x on both sides. That's going to give me a negative 16x. Then I'm going to add 15 on both sides. Nothing to combine with it, so plus 15. Bring down the equal sign. Don't forget your 0. So again, you have two options. You can try and factor it, guess and check, or you can quadratic formula. This one does factor. Again, you're looking for two numbers that multiply to 15, but add to negative 16. Your first term should be x and x. So like 5 and 3 is not going to work, so we're going to use 15 and 1 to multiply to a positive but add to a negative. They would have to both be negative. And then setting both of those equal to 0. Some of us can do that part in our head. If not, go through the steps. X minus 15 equals 0, x minus 1 equals 0. And you'll see that your two answers would be a 15 and a 1. Stop before you move on and circle your answer and check for extraneous solutions. Now, you want to go back to the original problem to check for those. So 15 minus 5, good, 15, good. Plugging in a 1 also would not give me a 0. So both of these answers are fine and not extraneous. There is one more problem over here for you to try, and I would definitely give that one a try, and you can check your answers with the teacher or with me next class. Okay, so that is where we're going to stop for today. We'll practice the other problems in this packet next class, and I will see you then. Best of luck with your practice.